Welcome back, ladies and gentlemen. Today we are just continuing with somewhat evaluating, mostly just applying our properties of rational exponents. I'm just going to finish going through the rest of these problems in case you were curious on how to do them. Maybe you tried them and you want to see if you got the right answers. All right, so the first one that we're looking at is 7 to the 2/4. Instead of 2 times 1/4, we multiply those together. So we could write that as 7 to the 1/2 or the square root of 7. I'd say each of those is about equal in terms of their simplicity. And since we don't know what the square root of 7 is, we can really leave it either way. Just again, depends on the directions. All right, over here we're looking at 5 to the 1/5, really minus 1, because of the exponent in the denominator. So that's going to end up giving us 5 to the negative 4/5, because 1 can be rewritten as 5 over 5. But we don't want to have a negative exponent, so we would rewrite that as 1 over 5 to the positive 4/5. Or, again, we could rewrite that as the 5th root of 5 to the 4th power, okay? And again, this is the situation where are we asked for a radical? Totally rad, man. Or a rational exponent. So just keep in mind, depending on the directions, that will give you a hint as to when you are quote-unquote done with this problem. All right, now we have 10 to the 1st minus a 4th. So that's going to leave us with 10 to the 3/4, or the 4th root of 10 to the 3rd. Now, in this situation, unlike in number 3, I would probably want to see, if you went the radical route, the 4th root of 1,000. Okay, that's not that difficult to evaluate, and in my opinion looks a little cleaner. But again, not a huge deal for that one. All right, we are looking at, let's distribute this negative in here. Here, you know what? And just to make sure we're getting a little color variety. All right, so we're over here on to problem number 6. So we're going to end up with 7 to the positive 3/4 times 7 to the 1/4. And then remember that these exponents get added together. So this is 7 to the 4. I'm sorry. It's not going to be 4/4 because we're going to have one of our exponents be negative. So it's going to be to the 3/4. So we can leave it, 2/4, guys. Might be 7 to the 1/2. We're going to reduce that. Or just like in problem number 1, the square root of 7. And you could put a 1 here if you wanted for the exponent, but you don't have to. All right. Now in number 7, I know it says that we are multiplying, but I think it actually makes more sense to just break these numbers down. So we're looking at the square root of 3 times 75 is 25 times 3. So really what I have here is I have the square root of 3 squared, right? Because multiplication is commutative, so I can rewrite that in any way I want. And the square root of 5 squared, both being multiplied together. I rewrote 25 as a power so that I could more easily see that my powers undo one another with their roots. So really I just have 3 times 5, which is 15. So that's our final answer over there. So I'm going to do something similar over here with number 9, and we're going to see if anything happens to simplify out with the radical. So 12 is 4 times 3, and 8 is 4 times 2. So I've got a whole bunch of 2's going on here. So it appears that I have the 4th root of 2 to the 4th times 3 times 2. Now, you can break this up. It's important for you to note you could break this up in a lot of ways. I could have written 2 to the 5th. I didn't because now I can more easily see, oh, that 2 to the 4th, those 2's are coming out of my root. So this is really going to be 2 times the 4th root of 6, because everything else that was under the root can't come out because there aren't enough of them to undo the root's index, okay? So that's 2 4th root of 6, 2 times the 4th root of 6. All right, number 19, it looks like just a straight up combining like terms. Our roots are already simplified, so we have 13 4th roots of 2. And by the way, you're adding those together because basically just counting up how many 4th roots of 2 you have. Same thing over here with 21. That's going to be 11 9's to the 1/4 power. I know it looks funky, but that's what it is. I mean, if you wanted to write 11 times the 4th root of 9, also fine. All depends on what the directions say. And then here in number 23, we cannot combine like terms yet. We need to find some perfect square, right? Index of 2 to reduce out. And 63, I happen to know, is 9 times 7. So I can take the square root of 9, which is 3. So I'm going to have 8 square roots of 7 plus 12 times 3 square roots of 7. So that's going to be 8 plus 36 around the square root of 7. So that's a grand total of 44 square roots of 7. And that would be my final answer for number 23. All right, rolling right along, I've got the fourth root of what's going to turn out to be 81. That's one way you could write that as a starting point. But again, I would actually go the route of rewriting this as the fourth root of 3 times 3 times 3 times 3. Because the breakdown of the numbers hopefully helps you more clearly see that I have 4 3's being multiplied together, which is going to undo the root, which is going to let me know that I get an answer of 3. In number 11, I'm going to go the route of division. I'm going to rewrite this as 128 over 4, so that I can rewrite this as the fifth root of 32. All right? And I happen to know that 32 is 2 to the 5th. So that's going to eliminate my root, and I'm just going to have the number 2 there. All right. Last but not least on this like simplifying run of things, just straight up simplifying, 208. Let's say you're looking at 208 and you're like, I have no clue what I can do with that number. Like, I think I'm just going to leave it, right? That's what you're saying to me right now, Mrs. Fry. I'm just going to leave the fourth root of 208 as is. Do yourself a favor and just ask yourself, is this number even? And yeah, it totally is. So let's just start breaking it down. So we're going to, if I divide it by 2, I'm going to get 104. Okay, if I divide it by 2 again, I'm going to get 52. Sorry. 52 and 2. If I look at 52, that's still an even number, so I'm going to divide that in half, right? And so I'm going to get 26 and 2. 26 is even, so I'm going to get 13 and 2. Now I want you to look, even though you may not have expected it, there are 4 2's hiding in 208. So 208 is actually divisible by 16. We just didn't know it yet. You don't have to know right away, but you do have to make, different efforts, try different things to figure it out. And it's not time consuming to do that. Like, how long did it really take me to just break that down by dividing it by 2 over and over again until I got a number that wasn't divisible by 2? It took me longer to talk about it than to do it. Okay, so really what I have is the fourth root of 2 to the 4th times 13. So the fourth root gets undone by the fourth power, and so I'm left with 2 fourth roots of 13 for number 13. All right, number 15 is a problem in which we are going to rationalize the denominator. Now, before we do that, we're going to simplify this. So I'm going to rewrite this as the square root of 5 over the square root of 27. And the square root of 27 has a perfect square in it. It's really 3 square root of 3. And so this brings up an opportunity where I can talk about you only need to multiply the top and bottom by the root that you need. So I just need to multiply by 3 to the 1st, so that, like the square root of 3 to the 1st, so that when I multiply the two roots together, I end up with 3 square root of 3 squared. Remember, my goal when I rationalize is that the root gets eliminated by the power underneath it. That's the goal. And then I'm left with the square root of 15 in the numerator. So I now have the square root of 15 over 9, okay, because the 1, 3 underneath the root is now outside, and it's being multiplied by the 3 that was already outside the root. And no, those do not simplify because the square root of 15, the 15's inside, and the 9 is outside the root. So this is our final answer. And remember, that's just to eliminate the root in the denominator. Okay, now over here in number 16, you needed to use the conjugate in order to eliminate the root in the denominator, and so that would have been 2 minus the square root of 3, that factor, 2 minus the square root of 3. And so then I would end up, when I multiply, with 2 minus the square root of 3 in the numerator, and I would end up with 4 minus the square root of 9. So I would end up with 2 minus root 3 over 4 minus 3. So that's just 1. like the denominator's 1. So this is really just 2 minus root 3. Isn't that wild? This is one of the reasons why we rationalize, because then sometimes things become super nice like that. By the way, I do want to point out there were 4 terms under here, but remember the middle 2 add to 0 because it's the conjugate that we're working with, okay? And if you don't believe me, I'll show you that a little bit more clearly with number 18. So 8 and then root 2 plus root 5, we're going to multiply by the conjugate because we have 2 terms in the denominator. So root 2 minus root 5, root 2 minus root 5, so that's our conjugate. Okay, so I get 8 roots of 2 minus 8 roots of 5, and then I get the square root of 4. I get the negative square root of 10. I get the positive square root of 10. And then I get negative square root of 25. So every time you use the conjugate, this happens where the middle 2 terms are a positive and a negative of one another. So they're opposites. So they are eliminated. So I am left with 8 root 2 minus 8 root 5. They cannot be combined because they have different roots. And then the square root of 4 is just 2. The square root of 25 is just 5, so 2 minus 5. So I get 8 root 2 minus 8 root 5 over negative 3. Okay, and again, you could leave it like this, or if you wanted to, you could write it as 8 root 2 over negative 3. I guess it'd be plus 8 root 5 over 3. Your call on how you want to split that up as one fraction or 2 separate fractions. Not a big deal to me. All right, ladies and gentlemen, thanks so much for listening. Hope this helped you if you were still having any lingering confusion about how to simplify with all of these different properties that we have available to us. And keep in mind, some of these problems can be done in multiple ways. I'd say the ones I just did, these guys on rationalizing, there's only really one way to rationalize a fraction, but a lot of these other problems that I covered, there are some slight variations on how you could go about doing your work, but you should still arrive at the same answer, regardless of how you did that work. All right, hope you have a good one. Thanks so much for listening. Bye.